Okay, thinking back to key stage 3, all you've done before, let's make sure that we know all of the basics required to begin thinking about atomic structure. So, everything around us is made up of 92 naturally occurring what? Naturally occurring elements. Those elements are in all of the things that you can see at the moment. Sometimes they appear as just elements, and sometimes they combine to make something called compounds, but we'll talk about that later. But each of these elements, if we break it down into its simplest particles, they consist of atoms. Atoms are simple particles. Right? That doesn't mean that atoms can't be broken down, but they're the simplest particles that make up the things around us. What's in an atom? Again, you might have heard these terms before, but we're going to go over them now just to make sure we're all starting from the same place. An atom consists of protons. And protons are in the nucleus. The proton is in the nucleus of the atom. The protons here are indicated by the red spheres. Going around the atom, we have electrons. The electrons are in special places. They're like orbits that orbit the atom. Again, we'll talk about that in more detail. And then in the nucleus of the atom, we also have another particle called a neutron. The neutrons combine with the proton to make the nucleus, and together they are known as nucleons. Nucleons. Now, if you think about it, you know from previous experience that protons have a positive charge. So the neutron has a job in the nucleus. See if you can think about what it might be. Protons, they're found in the nucleus and they are nucleons. Electrons are found around the atom at different distances. Around the nucleus, at different distances. Protons have a positive charge, electrons have a negative charge. Neutrons found in the nucleus and they are called nucleons. These are the simplest subatomic particles. So if we take an atom, we start breaking it up, these are the first particles that we encounter. This theory, these ideas about subatomic particles have really only been around for just over 100 years. The electrons and the protons were found first. We'll talk about that in a minute. And Niels Bohr in 1913 proposed this basic structure for a hydrogen atom with a proton at the center, the nucleus, and an electron going around the proton. It's worth spending a little bit of time looking into the history of physics and chemistry, and it's worth looking up the life work of Niels Bohr. Now, as the atoms get bigger, obviously things get more complicated. So here we've got a bigger atom, we've got more protons and more electrons. We need to think about how we're going to identify atoms. Which atom do you think this is? Which element does it belong to? How could we work it out? Definitions that we need to have. The proton number, also known as the atomic number, is very simple, as the name implies, the number of protons in the nucleus of the atom. The proton number tells us which element the atom belongs to. The nucleon number, also known as the mass number, is the number of all of the particles in the nucleus. So that's protons and neutrons. It's the number of the protons and the neutrons added together. If you look back at the previous atom, count the number of protons, you'll know which element it belongs to. Right, we need to know the basic details and quantities that apply to each of these subatomic particles. So we'll start with the proton. The proton, now relative mass means that its mass compared with each other. So if we give the proton an arbitrary 1 mass, then we'll compare other things relative to that 1. So the proton has got a mass of 1. It's sometimes called an atomic mass unit. And it has a charge of +1. Again, look back at discoveries of these particles. They're very interesting. Electrons have got a tiny mass. It's about 0, but it's just above 0. It's 1 over 1,836th of a proton. And that's a number you need to remember. Its charge, -1. The neutron, we consider it to have the same mass as the proton. It's got a relative mass of 1, and the neutron has no charge. It took a lot longer. If you look at this, the electron was discovered first by Thomson at the end of the 19th century. And then Rutherford, although they thought that these particles existed, they had to prove they existed, didn't really prove it for another 12 years. Then it took quite a long time for the neutron to be, first it was suggested, but for it to be discovered. Why do you think that was? It's to do with the fact that protons and electrons have charge, so they do things, whereas neutrons, they just have mass. They're not affected by electric or magnetic fields, so they were harder to prove their existence. It's worth stopping and having a look at those videos. They're really interesting. And there's a video there, there's a link to everything we've talked about so far, just to make sure you've understood the basics. Right, let's get on to using symbols. This is the classic symbol, where we have the mass number or the nucleon number at the top, the atomic number at the bottom, and then the symbol for the atom, the chemical symbol for the element is the larger letter. So we can practice doing this. If we think about sodium for a second, if you look at your periodic table, now your periodic table is quite strange. They changed this a few years ago. So you have the mass number at the bottom and you have the proton number at the top. So that proton number goes at the bottom for sodium. Let's say sodium's got 11 protons. The mass number or the nucleon number goes at the top. And that's the number of protons and neutrons. So if we want to know how many neutrons the nucleus has, we do a subtraction. 23 subtract 11, 12. So 11 protons, 12 neutrons make 23. You try writing the proper symbols for helium and calcium using your periodic table. By definition, an atom is neutral. And if something's neutral, it must have the same number of positive and negative charges. So it must have the same number of protons and electrons. It's worth watching the video on atomic number just to consolidate some of the new information that you've been given. Okay, I have a read of the pages indicated and do the questions.